Fundamental of GIS. Series of GIS people. Number 13. Gerard Heuvelink, geostatistician. Understanding the limitations of spatial data and spatial models is essential both for managing environmental systems effectively and for encouraging safe use of GIS. Gerard Heuvelink of the Wageningen University and Research Center, the Netherlands, has dedicated much of his scientific career to this end. Through statistical modeling of the uncertainty in spatial data and analysis to the ways in which uncertainty is propagated through GIS. Trained as a mathematician, Gerard undertook a PhD in physical geography, working with Professor Peter Burrell of Utrecht University. His 1998 research monograph, Error Propagation in Environmental Modeling with GIS, has subsequently become the key reference in spatial uncertainty analysis. Gerard is firmly of the view that GIS scientists should pay more attention to statistical validation and exploration of data, and he is actively involved in a series of symposia on spatial accuracy assessment in natural resources and environmental sciences. The website is www.spatial-accuracy.org. Gerard's background in mathematics and statistics has left him with the view that spatial uncertainty analysis requires a sound statistical basis. In his view, understanding uncertainty in the position of spatial objects and in their attribute values entails use of probability distribution functions and measuring spatial autocorrelation with uncertainties in other subjects in spatial databases. He says, I remain over the last 15 years. He says, I remained disappointed with the amount of progress made in understanding the fundamental problems of uncertainty over the last 15 years. We have moved forward in the sense that we now have a broader view of various aspects of spatial data quality. The 1980s and early 1990s were dedicated to technical topics such as uncertainty propagation in map overlay operations and the development of statistical models for representing positional uncertainty. More recently, the research community has addressed a range of user-centric topics such as visualization and communication of uncertainty, decision-making under uncertainty, and the development of error-aware GIS. But these developments do not hide the fact that we still do not have the statistical basis right. Until this is achieved, we run the risk of building elaborate representations on weak and uncertain foundations. Gerard and co-worker James Brown from the University of Amsterdam are working to contribute to filling this gap by developing a general probabilistic framework for characterizing uncertainty in the positions and attribute values of spatial